Alright, so today I'm working on my NES emulator again. I'm working on sound, so I'm at the beginning of that process. So there's a number of channels that the NES so the NES synthesizes sound, so it generates waveforms, and it has a number of channels to do that. There's two square wave channels, often called pulse channels, and like the documentation from like the NES dev wiki, it's the main resource I use. So in my code base, it's called the two pulse channels. Those are square waves. Then there's one triangle wave channel, one noise channel, which is used mainly for drums and stuff. And then there's a, what's it called? Like a DCM. Basically, there's another channel that you can actually play samples from. Anyway, I've implemented the pulse wave channels yesterday. Well, it's taken a long time to get these things working, but yesterday they're finally working. Yeah, so I can show you what that's like. I'll play Mario. This, I think, just has one channel on right now. Yeah. Excuse me. So yeah, that's just the Pulse 2 channel. You can turn them. Yeah, let me turn them both back on. You can see. Well, I gotta recompile. Yeah. Yeah, so I got the pulse channels working, which is pretty awesome. And now the next one I'm going to do is the triangle channel. So let's figure that out. So basically, at a high level, I guess the way that sound happens on the NES is that cartridge has code, right, that can instruct the CPU to basically write different values into the APU, which is the audio processing unit, which is the chip that handles sound. Interestingly, on the NES, it's actually a single chip. So the 6502 is the CPU on there, and they had a custom chip made that has the APU and CPU combined on a single chip. But anyway, yeah, so it writes to different registers in the APU to control different properties of the waveforms that it generates. And so if we go look at like this write, whenever the CPU writes to the APU, you can see like the first like 4000 to 4003 controls the first pulse channel. So if you write to 4000, that controls the volume. You can control the sweep, frequency, which is like the pitch. Then there's a length counter, all those things. So the way it's controlled is by poking values into registers in the APU. So I have the pulse channels here, and we need to do the triangle. So best reference is the NESDev wiki, so like nesdev.org, I believe. That's the one. Just the APU here, and the triangle channel is what I'm going to be working on. Alright. So these are the registers that control the triangle channel. So it has like a step sequencer as well, looks like. Interestingly, it says silencing the triangle channel halts it, so it continues to output the last value. It doesn't, like, mute it. There's no way to reset the phase. Okay, well, and what does this say? As well as a high-resolution linear counter control. Uses a 7-bit value written in 4008 directly instead of a lookup table. Okay, well, let's see. We're gonna have 4008. Which is, so the length counter halts, linear counter control is C, so there's a single bit for that, and then linear counter load is the rest. 4009 is completely unused. Timer and length counter. Yeah, so I've done the timer and length counter similarly for these two. You can see, so it's a 16-bit, well actually it's 11-bit value. You got 8 bits here and then 3 here, but I'm using a 16-bit variable to hold it. So yeah, like you can see here, you take, if you write to 4006, that's the low 8 bits, you just stuff that into frequency timer. They write to 4007, you pull off the high 3 bits, and stuff that in. So we're going to do the same thing here, it looks like. Except it's not a frequency timer, it's just timer. So well, I guess it is the frequency timer. The pitch is 1 octave below the pulse channels with an equivalent timer value. Use the formula above, but divide the resulting frequency by 2. What formula? I don't know what it's talking about. So we can change all those at once. 9 is unused, so it's A and B is what we need. Right, so low, then high. Length counter load, yeah, so that's the same too. I'm imagining it works the same way. So it says there's no way to reset phase, so that's not gonna happen. Does the length counter load only happen if it's enabled though? Figure that out. Yeah, it doesn't read from a length table though. It said that has no volume control, it has a length counter. Instead of a lookup table like the length counter. Okay, so the length counter is a lookup table, but this linear counter control is not. Yeah, let's go in here. Yeah, so it looks like the length counter uses that same table, I think, so that's probably the same. Um, hmm. Alright, well, let's see. Do we even have a triangle channel, like a data structure for that? We don't. So, yeah, you have two pulse channels, then you're gonna need tri-channel. Yeah, so in this code base I'm using like this whole like type T thing, which I don't know, I don't hate it, but I've kind of changed styles now, but I'm trying to, you know, stay consistent in this project with the old style, but nowadays I would just call this frame sequencer, like that. But anyway, we need a tri-channel. So, inside of there, what's all the shit that we got? We got timer, link counter, all of this. Which, pulse has a lot of that stuff. We got the frequency timer, length counter. And the sequencer. So in the pulse, I think that's like what the duty counter is. What is this sequencer? Sequencer continues over a sequence. Yeah. In this, clocking a sequencer usually means either advancing to the next step in a waveform or the event sequence of the frame counter device. Right. Uh-huh. So I think I have some like to-dos about this. What was that? Like half frame and stuff. Tick half frame. Yeah, tick other channel length counters. And then the quarter frame. Yeah, so here I'm supposed to do the linear counter. I kind of lost my train of thought. Right, so we need to fill out this guy. So there's a control flag and a counter reload. Actually, you know what? There's a really good like really, really good post in the forum by Dish. He posted some pseudocode about how to implement like these channels. So here's the triangle. Right, so the triangle's clocked at the CPU clock. The other channels are half the CPU clock, so we'll have to remember that. Interference. When the frequency timer is less than 2, it goes ultrasonic and is effectively silenced by forcing output to 7.5. This causes a pop. 415 read write. Same as pulse, only uses bit 2 instead of 0. Okay, so apparently you can read APU read 415. Length counters. Right, so triangle length counter, it's bit 2. So let's look at the NES dev on this. 415. Right, so this is just telling you which channels are enabled. So pulse 1, 2, triangle, noise. Okay. So now we just gotta do the noise channel. So that's a 415 read, a 415 write. So that bit. Triangle enabled. So this is saying if it's not enabled, you set the length counter to 0. Does that happen here as well? Writing a 0 to any of the channel enabled bits will silence that channel and immediately set its length counter to 0. Is that also true for triangle? Because wasn't Dish saying to silence it, you stop clocking the tri-step unit but do not change its output? This is in contrast to other channels where you silence them by forcing output to 0. I mean, it does say that 415 touches the length counter only. Let's assume that it does. Make sure that guess because this kind of seems to imply something else. Okay. Alright. So we got a 4008 right. It's just linear control, length enabled, linear load? $4,008 a right. Oh, okay. Yeah, here's some stuff. Great, so 415, turn off the channel, which will clear its length counter. Great, so we clarify that. To resume, turn it back on via 415, then right to reload the length counter. Yeah, this is what Dish was talking about. Interesting. I love Mega Man 2. I don't know, can I even run that yet? Mega Man 2. Nah, I haven't implemented that mapper yet, I don't think. Mapper 1, yeah. I don't have mapper 1. Not yet. Is there another Mega Man? No. The light counter, linear counter can be used automatically. Halt the triangle after a period of time. So, 4008 right. Counter reload and control flag. Counter reload and control, but what about enabled? Oh, that's control. So control is enabled. Wait, what? Oh, he's just having two variables that's like the same thing, just... yeah. Two ways to refer to, you know, sort of the opposite concept. Okay. So how do we want to call it, right? So if it's enabled when it's not set, is that what it is? Control flag. This bit is also the length counter halt flag. So these also have a length counter halt. What do I call it there? Let's look at a right to like 4,000. It would be bit 6. What? I don't have a bit. Duty. What? Duty cycle is this. Then loop. I call it loop. Halt length counter. This bit is also the envelope's loop flag. That's why I called it that. Halt flag, envelope, loop flag. What does that do? With optional looping. So it just tells you where to loop or not? Linear control, linear load. Linear control. Linear load. Maybe we'll call it that. So that could be a bool, I guess. And then linear load, it's gonna be 7 bits, so we can use an 8-bit unsigned integer. Okay, so a write to 4008 is triangle linear control. Right, so we're gonna have data 5, 6, 7. Right. Control. And then linear load is the low 7 bits. So linear load is data and what would be the low 7 bits? 7F? 4, 5, 6, 7, right? Or yeah, 7F. Huh. Right, he sets enabled. Okay, so that suggests that when that bit is set, length is not enabled. When that bit is clear, length is enabled. So yeah, it's like the halt flag. So it's kind of like a negative. Yeah. Well, that should be okay for 4008. If we have 4000. Frequency timer. Yeah, we did that. Wait, 9. Right, 9 does nothing. A does the low. B does the high. And then if it's enabled, length counter gets the value from the length table. Linear reload gets set to true. Linear reload? We called it linear load. Is that the same? Probably. Linear load. Linear load. Uh-oh. Is linear reload and linear load. Huh. So 4000B right sets the linear counter reload flag. So you have a load value and a reload flag. So I should probably call them that. Counter reload value. Linear load. Linear reload flag. Could do that. So we have the reload flag, the value to load it with. Sure, so when you write to here, you can set the reload flag. And then we set the load there. That's right. So that's all for register writing. It's pretty simple, I guess. Cool. 8, 9, 10, 11, okay. Just double check. Nothing's obviously fucked up. Can we compile this? Right, you have no enabled. Ah, I see. So yeah, that's why he wanted this enabled thing. So that's also the linear control. Yeah, honestly, it makes it understandable to have both. So we'll just do both. Memory is cheap. And we want to understand what's going on. So we just do this. Linear enabled. Control. Oh shit. My girlfriend is calling. I'm gonna pause.